Select the major products of the following reactions. So we have a reaction where we are starting with an alkyl halide. The reactions that we have covered of alkyl halides have been substitution and elimination reactions. And for those, we have a few different pathways that the alkyl halides could undergo. And so we need to first decide, before we get into the products, what the reaction is going to be. What pathway is this going to follow? And so to analyze this, the first thing we do is we want to say, what is the structure of our alkyl halide? And so if we look at this alkyl halide, the halogen is attached to the end of the chain, so it is a primary alkyl halide. And additionally, it is allylic. It is the carbon atom, one carbon over from a pi bond. So this is a primary allylic halide. And unfortunately, that doesn't tell us which reaction pathway it undergoes. A primary allylic halide could undergo an SN1 reaction. It could undergo an SN2 reaction. It could undergo an E1 reaction, and it could undergo an E2 reaction. So the next thing we're going to do, since we haven't narrowed it down at all, is we're going to look at the identity of the base/nucleophile. And the only thing we have in here is water. So water is going to behave as both the solvent and a reactant. So this is a solvolysis reaction. So our base/nucleophile is water. And so we need to know, is this a strong base? Is this a strong nucleophile? Or is it a weak base and a weak nucleophile? And neutral water is a relatively poor base and a poor nucleophile. And so this means that we are looking at one of the stepwise pathways. So it will not be an SN2, it would not be an E2. Those pathways would require a stronger base or stronger nucleophile. So we need to consider SN1 and E1. And so additionally, what we're going to look at here is the temperature. And now the temperature isn't indicated in this case. If we wanted to push the reaction down an E1 pathway, we would probably indicate heat. And since it doesn't tell us that we are heating this reaction up, we will assume that the major product will be from the SN1 pathway. And so we need to draw the mechanism of this pathway to figure out what substitution products we're looking at. That's an elimination product, and that is not something we should consider. So let's take a look. So in an SN1 reaction, the first thing that happens is your leaving group leaves. And so that would give us this resonance stabilized carbocation. So we can draw the resonance form. And since we have these two resonance structures, this indicates to us that we have two carbon atoms that are electrophilic. The water could add to either one of those, giving us this alcohol and this alcohol. So we would have a mixture of these two products, which is option A.